So I'm going to just do a couple of worked examples of trig before your exam. So for example, I've got this two triangle problem here. I know that these are both right angles. I know this angle here is 28.3 degrees, and I know these two lengths. The hypotenuse of this triangle, which is 24.92 centimetres, and I know this length here, 15.37 centimetres. Now, in a case like this, you might be asked to solve it, so that would mean working out all of the lengths and all of the angles in the whole diagram, or you might be asked for a very particular length. In this case, I'm going to solve it, and you can see exactly how you get all of the different things. Now, the way I'm going to go about that is I'm going to start off with the easiest things. So I'm going to start off with this angle here. I'm going to call it A. And if I just take this triangle here, I have two angles, and I don't know a third, and I know the total number of degrees in a triangle is 180. So A is equal to 180 minus 90, which is this right angle here, minus 28.3. So A is equal to 61.7 degrees. So now if I carry on with this first triangle here, I know that the longest, the thing opposite the right angle, the longest one is called the hypotenuse. If it's a right angle triangle, it's the one opposite. And so I know that the sine of A is equal to the opposite over the hypotenuse. And I know that A is equal to 61.7, so I know I can work out what the sine of A is, and I know the opposite in this case. This is this length here, 15.37, so I'm going to be able to work out this length here, the hypotenuse of this triangle. If I do that, I end up with the sine of 61.7 is equal to 15.37 over the hypotenuse, and I'm just, for the sake of this, I'm just going to call this Z, so over Z, just to make it easier to write. And so if I just do a little bit of rearranging, that means that Z is equal to 15.37 over the sine of 61.7, which is equal to 15.37 over 0.8805, which hopefully gives me a length of 17.46 centimetres. So now I know this length Z. The final thing I need to know about this first triangle is this length here. I'm going to call this one Y. And I can say that, for example, if I take Pythagoras, this is a right angle triangle, and I know that the square of the hypotenuse, this one here, if I take the square of it, is equal to the sum of the squares of the other two sides. So here I can say Y squared is equal to Z squared minus this one here, 15.37 squared. So this is equal to 17.46 squared minus 15.37 squared. And so if I were to work that out, I find that Y is equal to the square root of 68.56, which is equal to 8.28 centimetres. So this one here is 8.28 centimetres. So now I know everything in this. As far as this triangle here goes, so if I use Pythagoras in this case, I can work out this length here. So this is my hypotenuse here. So in this case, it's going to be, I'm going to call this x here. X squared is equal to my hypotenuse, 24.92 squared, minus this length z, which is 17.46 squared. So that is equal to the square root of 316.15, which is equal to 17.78 centimetres. X is equal to 17.78 centimetres. So this is this length here now. So finally, I just have these two angles to work out. I'm going to call this one here, I'm working on an angle now, so I'm going to change colour pen. I'm going to call this one here angle B. So B, sine B is equal to opposite, so this is x, 17.78 centimetres divided by 24.92 centimetres, and so B is equal to, or sine B is equal to 0.7135, and so B is equal to 45.5 degrees. And then that just leaves this angle here, C. I'm just going to squeeze this into the bottom because C is equal to 180 minus 90. So 180 degrees in a triangle minus 90 for this angle here, minus the angle B, which is 45.5 degrees. And so that means that C is equal to 44.5 degrees. This is very nearly an equilateral triangle. Very nearly, despite the figure. Don't let the figure ever fool you, yeah? So now I have solved this. I know everything in here.